What's up, scholars? Today we're going to talk about solving logarithmic equations. Now, I'm just going to let you know this is a good time. You're going to enjoy yourself. Alright, when we solve these equations, we either want to get our answer or to get our expression to look like this. Log base A of B equals C. Because then we could evaluate, like if we know A and B, we could evaluate this part, and then obviously that's what C is. We could put it back into exponential form and do A to the C equals B if we need to solve for what B is. Right? So we're either going to try to get our expression to look like this so we can evaluate it, or if we get something like log base A of B equals log base A of C, then we can set B equal to C and solve there. Okay? So try to get either this situation to happen or this situation to happen. Cool. Let's dive right in with an example. Alright, here we go. We are going to solve this for the unknown variable k. We have 4 log base 12 of k plus 2 equals 20. So clearly, we don't have 2 logs, so we're not looking for that situation. We're going to try to get this situation and use that to solve for k. Cool. So let's get the log by itself first. So let's divide everybody by 4. And we have log base 12 of k plus 2 equals 5. And then we can put this back into exponential form and say 12 to the 5th power equals k plus 2. 12 to the 5th power equals k plus 2. Let me get out our calculator. Now 12 to the 5th, I think it's going to be a pretty large number. There's 12 squared. There's, whoa, hold on. 12 times 12 squared, cubed, to the 4th, to the 5th. 2, 2, 4, 8, 8, 3, 2 equals k plus 2. Subtract 2 on both sides, so we get that k equals 248,830 equals k. Nice. Alright, now let's do an example of the other situation. Alright, this one, we got logs all over the place. All of their bases are the same. That is important. So we're going to try to get log base 6 of blah 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 equals log base 6 of 60, and then we'll set 60 equal to blah 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 and solve. Cool. We remember that when we are adding 2 logs with the same base together, we can condense that by taking these 2 terms and multiplying. So this is the same as log base 6 of 3 times x squared minus 5 equals log base 6 of 60. So let's distribute. We'll get log base 6 of 3x squared minus 15 equals log base 6 of 60. So this means that 3x squared minus 15 must equal 60. 3x squared minus 15 must equal 60. Let's add the 15 on both sides, and we'll get 3x squared equals 75. And divide both sides by 3. So x squared equals 25. And we take a nice little square root. And x equals plus or minus 5. Cool. Super cool. See, I told you this was a good time. I warned you. This is going to be quite a pleasant experience. It truly is. You know, let's just have some more fun, I think. Let's do some more examples. All right, here's our next beautiful expression. We've got log base 6 of 3x plus 14 minus log base 6 of 5 equals log base 6 of 2x. So we're going to try to condense the left side of the equation. So it'll be log base 6 of something, which will equal log base 6 of 2x. So we'll set 2x equal to that something and solve for our variable x. Now, because we are geniuses, we remember that when we are subtracting two logs, that means we can take what we are logging and do some division. Division. So this is the same as log base 6 of 3x plus 14 divided by 5 equals log base 6 of 2x. Sweet. Now, we've got log base 6 of something equals log base 6 of something. For these to be equal, those somethings have to be equal. So let's say 3x plus 14 over 5 equals 2x. Now you'll notice I didn't bother to simplify that, because 3/5 not super helpful, not very simple, and 14/5 also not what I'm trying to do with my life. And I know that I can get rid of that fraction lickety split if I multiply both sides by 5. It's like not even a thing, you know. We get 3x plus 14 equals 2x times 5 is just 10x. Subtract 3x on both sides, and we get 14 equals 7x. Divide by 7 on both sides, and we're going to get x equals 2. Dun 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 dun. Nice. I'm just having such a good time. Let's do another one. And check out this beauty. We got log base 4 of x plus 10 minus log base 4 of 3 plus log base 4 of 2 equals 2. So, I know what you're thinking. We're going to condense the left side of the equation. And then we'll probably do a little bit of loop swooping, putting it back into exponential form, so we can solve for this x here. And your thinking is correct. So, I see a subtraction sign, which means we need to take these two and divide them. And then we'll take our result here and multiply it, because that's a plus, by 2. Let's condense this chunk here first. That really means log base 4 of x plus 10 divided by 3 plus log base 4 of 2 equals 2. Now we put these two together. That plus means we can take these parts and multiply them. So this will be log base 4 of, okay, we'll do 2 times x plus 10 all over 3 equals 2. I am going to simplify this just slightly here. Log base 4 of 2x plus 20 divided by 3 equals 2. Alright, speed that up, give us some space for our looping and swooping. So we're going to say 4 to the second power equals this mess. 4 to the second power equals this mess. 4 to the second power, of course, is 16. 2x plus 20 over 3. Let's multiply by 3 on both sides. Oh god, I'm going to run out of space. We get 48 is 2x plus 20. Subtract 20 on both sides. We'll get 2x equals 28. Yeah, this is fine. 2x equals 28. We subtracted 20 on both sides. Divide by 2, we get x equals 14. Wham bam. Thank you, ma'am. All right, we have one more beautiful, beautiful question. We use our critical thinking skills. Are you ready? I think you are. All right, for our last example, my x got incredibly long. Looks like a y. We have two different logs. They're not related to each other in any type of way. We're going to talk about them separately. I'm just writing them both down. So let's look at the first one. Log base 3 of 1 over 27 equals x. What does this mean? This means 3 to some power equals 1 over 27. 3 to some power equals 1 over 27. 3 to some power equals 1 over 27. You know, we totally can solve this. Totally can happen. Totally. Yeah. Because 1 over 27 is the same thing as 27 to the negative 1 power. And 27 is also 3 cubed. 3 cubed. 3 times 3 is 9 times 3 is 27. Getting it? Getting it? And then we say, I know what to do with a power to a power. We multiply those numbers so that 3 times that negative 1 becomes negative 3. We've got 3 to the x equals 3 to the negative 3. And then, this is just too easy. It's just too easy at this point. We got the bases to be the same, so 3 to some power equals 3 to the negative 3. That means these exponents must be equal to each other. Means x must equal negative 3. Que fabuloso. Très bien. Bon. Alright. Now let's look at this other guy. Log base 8 of 32 equals y. What does that mean? Of course, that means 8 to some power equals 32. 8 to some power equals 32. Oh, what? Hold up. What? 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 Well, could we write these as something that has the same base? We can. We definitely can. 8 is the same as 2 cubed. So 2 cubed to the y. And 32 is the same as 2 to the 5th. Gesundheit. Little sneezer back there. And then, just like we did over here, we know we can take these exponents and multiply them. So we've got 2 to the 3y equals 2 to the 5th. Bases are the same. We can set these exponents equal to each other. So we got 3y equals 5. So y must equal 5 over 3, which is a gnarly decimal, so we're leaving it as a fraction. Why does that make sense? Well, we know 8 squared would be 64, which would be too big. And that number is clearly less than 2. And 8 to the first power obviously is 1, which is less than. So our number had to be somewhere between 1 and 2, which it is. All right. I hope you enjoyed this lesson as much as I did. It was wonderful. Such a good time. Looping and swooping. All right. Love you, scholars. See you next time.